Good morning, viewers at home. In our previous lesson on quadratic equations, we talked about factorization method and we look at some examples on how to use factorization method to solve quadratic equations. So this morning we are going to talk about completing the square method. This is another method of solving quadratic equation, completing the square method. But before we go into the method proper, we need to know how to make an expression a perfect square. For instance, if we have something like x squared minus 4x, how do you make this expression a perfect square? Step 1. The first thing to do here, look for the coefficients of the unsquared letter. The unsquared letter here is x. So the coefficient of unsquared letter is minus 4. So the coefficient is minus 4. I will multiply that minus 4 by half. That is 2 in 4, 2. I have 1 times minus 2. That is minus 2. That is the first step. Step 2. You square the result that you get here. Minus 2 squared. That is minus 2 times minus 2. That gives us plus 4. Then you add this result to the given expression. So that means we have x squared minus 4x plus 4. So this expression now is a perfect square. So we need this knowledge when we are talking about completing the square method. So now let's take an example on how to solve a quadratic equation using completing the square method. The first example here, if we have 3x squared minus 11x plus 10 equals 0. 3x squared minus 11x plus 10 equals 0. The first step here is to take your constant to the right hand side. What is the constant? Constant is that term that is not carrying the variable x. So the constant here is plus 10. So we have 3x squared minus 11x. When this one gets to the right hand side, it becomes minus 10. Then the second thing to do is to divide both sides by the coefficient of the squared letter, which is 3. So I'm going to divide both sides by 3. Divide both sides by 3. Our aim here is to make this x squared to have a coefficient of 1 so that we can express this expression as a perfect square. So now the next thing is to make the left hand side a perfect square, which is what we have explained earlier. So if you want to make the left hand side a perfect square, we will look for the coefficient of the unsquared letter, which is minus 11 over 3. So we have minus 11 over 3 multiplied by 1 over 2 like we did earlier. Whatever you have here, you multiply it by 1 over 2. So we have minus 11, 3 times 2, 6. And the next step is for us to square the result. Minus 11 over 6 squared. So now we are going to add this to the expression to make it a perfect square. But don't forget that we have an equality sign that we must maintain. So whatever you add to the left hand side must also be added to the right hand side to maintain the equality sign. So we have x squared minus 11x over 3 plus minus 11 over 6 squared equals minus 10 over 3 plus minus 11 over 6 squared. Then we have x, we take this variable x without square, then the factor in the bracket minus 11 over 6, then we square all equals minus 10 over 3 plus, if you square 11, you get 121. If you square 6, you get 36. So we have x minus 11 over 6 squared equals, now we are going to take the LCM at the right hand side. The LCM is 36. 3 in 36 is 12. 12 multiplied by minus 10, that is minus 120. 36 in 36, 1. Multiplied by 121, that is 121. So we have x minus 11 over 6 squared equals minus 120 plus 121, that is 1 over 36. So the next step now is to take the square roots on both sides. We'll take the square roots on both sides. If we take the square root on both sides, then we'll have x minus 11 over 6. We are taking the square root equals to plus or minus square root of 1 over 36. So this square root will cancel this sign. We have x minus 11 over 6 equals plus or minus square root of 1 is 1, square root of 36 is 6. So we have x equals, this will cross to the right hand side, 11 over 6 plus or minus 1 over 6. So our x equals to 11 plus 1 over 6 or 11 minus 1 over 6. We have 12 over 6 or 10 over 6. So x equals 6 in 12 is 2. We reduce this to the simplest form. 2 here, 5, 2 in 6, 3, 5 over 3. So these are the roots of this quadratic equation using the completing the square method. In our next class, we'll look at some other examples. Thank you.